In this question, if a block B shown in the figure is going down with the acceleration of 5 meter per second square, find the acceleration of block A. All pulleys and strings are ideal. Radii ratio of the two step pulleys are given as 1:3:5 and 1:2. So let us call this step pulley as X, this as Y, and let us call this as Z, and let us call this as P. So pulley X has the radii ratio of 1:2 and pulley Y has the ratio in 1:3:5. So let us assume that block B moves in the downward direction by X. Okay, block B moves in the downward direction by X. And let's also name the strings. We call this as 1, this is 2, this will be 3, 4, 5 and 6. So we say that let the block B moves in downward direction by X. Okay. So it means string 1 will move by X. Now string 1 and string 2 are connected to pulley X, whose ratio is given as 1:2. Okay, you can say that string 1 and string 2 are connected to step pulley with radii ratio step pulley X with the radii ratio 1:2. So it means the string 2 will shift to the right by x/2. So we can say that thus string 2 will shift to right by x/2. So we are going to have this string 2 will be shifting to right by x/2. The string 3 and string 2 are same. So it means string 3 will be moving in upward direction by x/2. Okay. So string 2 moves in this direction and string 3 will be moving in upward direction by the same amount, which is given as x/2. Okay. So string 3 move by upward direction by x/2. So as string 3 and string 2 are same, or we can say continuous, then string 3 will move in upward direction, then string 3 will move in upward direction by x by 2. Now the strings 3 and 4 are connected with the pulley y, which has a radii ratio of 1:3:5. Okay, so you can say that string 3 and string 4 are connected to step pulley y with radii ratio of 1:3:5. Thus we can say that 4 string will move in downward direction by a distance of 3x by 2. Thus string 4 will move in downward direction by 3x by 2. So we can say that string 3 moves by a distance of x by 2 in upward direction, and string 4 moves in the downward direction by 3x by 2. Okay, so therefore we can find out the slack between string 3 and string 4. So you can say that thus the slack between string 3 and 4 is given as 3x divided by 2 minus x by 2, and which is equal to x. Okay, so it means that pulley Z will be moving in downward direction by x. Okay, we can say that thus pulley Z will move in downward direction by x, and string 5 will move in the downward direction by x by 2. Thus string 5 will move by x by 2. Okay, therefore string 5 will move in downward direction by x by 2. Now string 6 is connected with the pulley y, and the ratio is given as 1:3:5. It means we are going to get the slack in pulley 6 will be coming as write this way as string 6 is also connected with pulley Y with radii ratio as 1:3:5. So it means the string 6 thus string 6 will move in upward direction by 5x by 2. Okay, so we can say that string 6 will move in upward direction by the amount 5x by 2. Okay, so the movement of string number 3 as well as string number 6 will be dependent upon, as well as 4 will be dependent upon this x by 2. Okay, so if x by 2, so ultimately the ratio is 5, so this will be 5x by 2, and middle ratio is 3, so string number 4 goes down by 3x by 2. So 4, 6 are both dependent upon the movement of string number 2. You can see that the string is connected to pulley Y with the radii ratio as 1:3:5. The string 6 will move in upward direction by 5x by 2. Okay. So now we can find out the slack between 5 and 6. Okay. Thus the slack between string 5 and 6, and this can be equal to 5x by 2 minus x by 2, and which will be coming as 2x. Okay. So we can say that this pulley P will be moving in downward direction by 2x. Okay, thus pulley P will move in downward direction by upward. Sorry, it will move in upward direction. Let me correct it. Upward direction by x. Okay, moving in upward direction by x. If pulley P is moving in upward direction by x, then only we are going to get a slack of 2x between 5 and 6. Okay, in the upward direction by x. This movement of pulley P in upward direction by x will result in the slack of 2x between string 5 and 6. So we can say that thus block A moves in upward direction by x. Okay. So in this case we are supposed to find out at the acceleration of block A. Okay. So we can write this as that the displacement of A, that is dA, is x. If you double differentiate it, okay. And another thing is that here the moment of block B we have taken initially as x. Okay, so we can say that block B also moves by x. So we can say that dB is also equal to x. So let us call this equation 1 and equation 2, double differentiating or differentiating 2 times equation 1 and equation 2. Differentiating two times equation 1 and equation 2, we get acceleration of A, okay, we get dx square by dt, and acceleration of B is also dx square by dt square, and acceleration of B, it is given as 5 meter per second square. So we can say that acceleration of A, block A, is nothing but 5 meter per second square. Okay. So both blocks A and B moves with the same acceleration. Okay, both block A and block B moves the same acceleration. So we can draw this conclusion. Thus block A and block B both move with same acceleration, which is 5 meter per second square. Thank you.